We see our rules for a series circuit here on the top right. Voltage adds up, current stays the same, resistance adds up, and power adds up. Now in parallel these rules are going to change. Here we have Ohm's law in all three forms and the power formula in all three forms. So let's begin with our first step. And we always want to begin by filling in what we know, filling in our knowns. So what do we know? We know that we have 240 volts for our VT. Next we can fill in all of our resistor values. So right here real quickly we're just going to add in all of our resistor values from each of the resistors. Based on the values that we are given, the first thing that we can actually solve for would be RT. And if we look at our rules for series, it shows us that RT is just the summation of however many resistors you are dealing with. So in this case we have 5 resistors, so we're just going to add all of those up. Our first resistor value is 22 k ohms. Our second one is 68 k ohms. Third one is 10 k ohms. Fourth one is 1 mega. Make sure you put the 6 for your exponent. And then R5 is the 100K. Gives us a total resistance of 1.2 mega ohms. Now that we have our total resistance, remember that we're always going to save power till last. If we can get 2 of 3 out of these 3 columns, we can solve for the third. So we have our VT and our RT now. So our IT is going to be equal to our VT divided by our RT, and our VT is 240 volts over our RT that we just calculated, and that tells me that I have a total current of 200 microamps. Now what do we know about current in series? Based on our rule here, rule number 2 we'll call it, current stays the same. So now basically I can fill in 200 amps for every one of my currents. Now that I've got all of my currents filled in, I was given all of my resistances, I can now calculate all of my voltages. V1 is going to be the 200 microamps times the resistance of 22 k ohms. That tells me I have a voltage drop of 4.4 volts across the first resistor. My V2 voltage drop, I'm going to go up here. I'm going to change the value of the resistor to 68 k ohms. Current stays the same, tells me that I have a voltage drop of 13.6 volts across V2. V3, I'm going to go up here again, change my resistor value to 10 k ohms, and my third voltage should be 2 volts. Now I know immediately that my fourth resistor is going to drop a lot more voltage because it's a much bigger resistor. It's a 1 mega ohm resistor. So my current stays the same at 200 times 10 to the negative 6, but now I have to multiply this by 1 times 10 to the 6th for 1 mega ohm, telling me that I'm going to drop 200 volts across R4 for my V4 value. Now my V5 value, I will go back up here, remove this again, put in 100 times 10 to the third, and that gives me 20 volts for my V5. I can check these by adding up V1 through V5, and they should total 240 volts. So I punch all my voltage values in, and they do equal 240 volts. So I did that part correctly. Now I can calculate all of my power. I'll start with PT. PT is equal to, as you see here, IT times VT. Gives me a total of 48 milliwatts. P1, we're going to just change our voltage to 4.4. Gives me 880 microwatts. My next one, I go up here, change the voltage amount, 13.6, tells me 2.72 milliwatts. Go up and change the voltage again to 2 volts, tells me 400 microwatts. .40 milliwatts on P4. P5 is 4 milliwatts. PT should give you the same answer two ways. PT should equal IT times VT. Then PT should also equal P1 plus P2 plus P3 plus P4 plus P5. If you get the same answer of 48 milliwatts both ways, then you know you did all of your work correctly. So I entered in all the values of my wattage, P1 through P5, hit equals, and it did all equal 48 milliwatts. So by checking PT at the end of your work and making sure that PT gives you the same answer when you do IT times VT and the summation of all your powers, this is really the greatest way to check your work.